What's happening in Genetics 311? This is our 7th and final exam mini video on phylogenetics. Phylogenetics is mainly concerned with the relationships between an organism and other organisms according to their evolutionary similarities and differences. In this video, we're going to be learning about phylogenetics as well as some other simple terms through analyzing a semi-fictional phylogenetic tree looking at computing devices throughout the years and the similarities and differences between them throughout their evolution. To begin, we're going to be discussing the items in green. First, we have the root. The root represents the common ancestor between all species in the phylogenetic tree. Looking at the groupings here, we have the top of the phylogenetic tree. You can see where over time, the devices have evolved to be more personalized entertainment and work, while the bottom devices or species have evolved to be more home-oriented, ease of access forms of devices. The close grouping on the tree represents the small amounts of differences between the two species, while the longer branches represent more differences. Anagenesis represents the evolution of a certain species within its own branch on the tree. For example, with the desktop computer, they have advanced over time and have become much quicker, but they're still the same species in the end. Cladogenesis is the phenomenon that refers to the divergence of species within a phylogenetic tree. They are represented at these internal nodes, the green squares, where they represent the common ancestor between two species on the tree. If we take a look at the four species sectioned off from the rest of it, the desktop species can be looked at as an outgroup compared to the other species on the upper part of the phylogenetic tree. This desktop or this outgroup species will ultimately have more genetic differences than the other three species. To finish out, we're going to talk about operational taxonomic units, or OTUs. Looking at the phylogenetic tree overall, we have two OTUs here, where we have the top four species being closely related and the bottom four species being closely related. Obviously, the species with the most recent common ancestor and the shortest branches are going to have the least genetic differences, and the ones with the longer branches are going to have more differences. But overall, this group, this OTU, is going to have genetic similarities. In this example specifically, this OTU has their genetic similarities rooted in their computing power and speed. As well as this OTU, their computing power is minimal compared to the other four species, but they are all grouped together based on their similarities. That is all. Thanks for watching.